So far, we've taken a look at data structures that allow us to be able to access and work with data in a particular way, say a last in, first out, a first in, first out, or in the case of our linked list, we could really retrieve data from any location. And these were all really great for the purposes of just being able to store, access, and work with data. However, in some cases, we also want to be able to search data fairly quickly. And that's where our new data structure of a hash table is going to come in. So to help to demonstrate this idea, I've created this user class, and this user class may represent a user in an application. Say you have like a web application and every user has their own ID associated with them. Then they have a bunch of data associated with them. I just have a username property here, but they could very well have more pieces of data associated with them. And the idea is that if they were to do something on an application, say think like visiting a profile page, I may want to retrieve all of their data with just the ID available to me. So far, we've seen this idea of a linear search where I could search through an array and I could try to find the ID and then, send back that data. But that linear search can be a little bit slow, especially if our data is particularly large. So we need a bit of a better way of being able to search through data, and that's where one of our main approaches, the hash table, is going to come in. For this video, I'm going to introduce to you a simplified version of a hash table called a direct address table. The idea of a direct address table is that we want to try to let one of the unique identifiers of the data that we're storing act as the index for that data, so the location of that data in memory. So I'll give you an example, right? If you had an array of values, right, maybe something like this, we know that we can access data at a particular index in constant time, right? No matter what, if I want to get to any index, it's constant time. We just add the offset and we're at that location. So it goes to stand that if I can make the index the identifier of my data, and then I store the rest of the data at that index, I can very quickly get to that index to retrieve the data. I would have a constant time retrieval of the actual data itself. That's the main idea of a direct address table. So let me show you more explicitly how that's generally going to work. So suppose that we had some users inside of our application. So I'll just create a few different users. We'll have a user with an ID of 0, and we'll just give them some different names, right? And I'll have one with an ID of 1, and I'll just do another one with an ID of 2, right? So we'll just put in a few different ones here. And then if I were to construct a table or a list of these users, right? So I could call this, I'll just call this L to represent a list, and it's going to contain those different values in it, right? Notice that the ID of each user matches the index that I placed it at inside of the list. Now, if I want to be able to get user data, say that I had like a function get user data, all this function is going to need from me is the ID of the user, and it will be able to find that user inside of the list, right? All it would do is it would just return L at ID, right? That's all it would need to do in order to retrieve the data. So you can see here that in this case, given an ID, we would be able to find the data associated with that ID in constant time. So this is really great. The reason why we don't necessarily use this too often, though, is because the number of IDs that we have may be large. We maybe have hundreds and thousands of IDs, and it can actually get like prohibitively large to store inside of just one list of data. Or generally, we could have our IDs being a bit more dispersed. Maybe we have an ID at value 0, one at value 1000, one at value 3000. In this case, the data is so spread out that we have all this wasted space that we're not really using. So because of that, we want to try to find a better approach to this problem. Rather than just direct addressing, saying the ID is the index in an array, and then we can do a constant time lookup, we want to do something a little bit different, and that's going to be the idea of our next video. We're going to dive into this idea of how can we more evenly distribute out the keys that we have, those ID values, how can we manage to map them down into a smaller set of possible values, and how can we handle those sorts of situations. So that's the main idea of what we're going to take a look at in the next video. So thanks so much for watching. I'll see you in the next one.